Hello class, this is Dr. Kamal and this is a video about sampling. I'll give you some not so many details but good enough details to get you started on the sampling topic. The sample is basically a subset of the population. So if you have a population like this, say a population of cars in the parking lot, if you grab some sample, you grab a subset or a portion or a part of that population. The only condition when you collect the sample is that the sample is random, because the population assembly itself is random, and therefore the sample has to be random. And in the statistics and business analytics, we assume that everything in life is random, all the events are random, and this is part of being normal. So randomness is part of normalcy, and we use that with the data as well. Why do we take sample instead of studying the entire population? Of course, because it is very costly. You can destruct all the items of the population. For example, if you are a car maker and you want to crash test your cars to make sure that they're solid and they can protect the passengers, if you test every single car you make, you will have nothing to sell. So therefore, destructive testing is not recommended, and you need just only to test a small sample. Of course, the impossibility of larger population, like the population of planets, the population of sand particles, these are all the tree leaves, etc. These are all impossible populations to measure, and therefore we only take samples. The population is an existing units of people, objects, events, or measurements. Like there's a population of weights of everybody. There's a population of blood pressure measurements. So there's a population of eyesights, etc. So there is a humongous population of anything and everything you can imagine all over the universe. But we look only at data, so there is population of data on anything that you can think of. A variable is a measurable characteristic of the population. It can be quantitative, meaning it's data, it's numbers, or qualitative, it's a category or a description. And census is an examination of the entire population, basically counting. A sample is a subset of this population. As we deal with samples and population, once we collect the sample, we like to describe it, and it's called descriptive statistics. It helps us to describe the population if possible, and this is the ultimate goal. We describe the sample because we want to understand and know the description of the population. And we use other measurements to infer more data from population. It's called inference or statistical inference, because we try to infer more data, more information about the population from the sample measurements that we collect. These types of sampling are all random. So there's what we call a random sample. The sampling with replacement is also happening in a random way, but it's basically you take a sample and then you measure it and then you put it back, and the items can be put back into the population to be selected once again if this is needed. Like measuring babies, for example, you don't destroy the sample, you take measurements, you take the baby, a newborn, and you take some measurements and then you put it back into the nursery, whatever, and then you take more measurements, so the sample is being tested, repeatedly replaced. Or sampling without replacement, this is when you destroy the items. It's very important that we have random samples, and some samples may not be totally random, so we approximate that by a frame listing of all the population units. Systematic sampling, like in shifts, every third shift you take a sample, or if you have in manufacturing or industry, every so machines you take a sample from the machine. That's called kth element. Voluntary response sample, this is when you do a survey, like vote for somebody on TV. This is all voluntary response, is assumed to be sample as well, because they have no control over the people when they select something. This is very important to pay attention to. We differentiate between population parameters and sample statistics. They are basically measuring the same thing, but they have different names. A population parameter is a number calculated from all the population data. For example, the population mean, the population sample, standard deviation. There's also a sample mean and a sample standard deviation, but the sample mean and sample standard deviation are called sample statistics. The population mean and population standard deviation are called population parameters. Sample statistics are considered point estimates of the population parameters. So here is the population, and it has its parameters. We call them mu for the mean. So the population mean is mu. The population standard deviation is sigma, and these are the Greek letters. The sample mean is x bar. It's called x bar. It's the letter x, and it has a bar on top. And then the sample standard deviation is s, small s, not capital S. It's a small s. We would like to describe the data of the sample, and we use something called descriptive statistics, where we measure the location of the center and the spread of the data around the center. We call these the measurements or the measures of central tendency and the measures of dispersion. And then we try to graphically place the data in a graph or in a funny way. We basically take a photo of the data, and we call this frequency distribution. The measures of central tendency are the mean, the median, and the mode. The mean is the average. The median is the middlemost point. If you have odd numbers, it will be the data set is odd. Then you will take the middlemost point, and if it's even, then you will take the two middlemost points and average them. The mode is the most frequent value on the data set. Here is the difference between the mean of the population and the sample. Notice how we write these up. Population is large, x1, x capital 1, x capital 2, until xn. It depends. N is the however many numbers within the population, which most of the time we don't know. The sample is x small 1, x small 2 to a small n, which is however many data in the sample. This is mu, and this is x bar. Population mean is mu, sample mean is x bar. Don't get overwhelmed with the mathematical term here or the mathematical equation. Basically, this means the summation, or basically the add up of all the large x's from 1 to however many n, capital N, divided by their count, which is how many they are. That gives you the population mean. X bar is the same way, the summation or the add up of all the x's from x1, the first data point, all the way to n, which is the last data point, all divided by the count or however many data points we have. The sample mean, x bar, is defined as such. Basically, x bar equals the summation of xi from 1 to n divided by n, which is x1 plus x2 plus x3, and is considered a point estimate of the population mean, mu. So x bar is a point estimate of mu. Here is a sample, an example. Say 5 different people took the same trip with their cars, and each one measured a different number of miles. The first person drove 30.8, 31.7, 30.1, 31.6, 32.2. So what is the average miles for this trip? We add all these numbers up: 30.8 plus 31.7 plus 30.1 plus 31.6 plus 32.1 divided by 1, 2, 3, 4, 5 of them. That will give us an average mileage for this trip of 31.26 miles. The median is the middlemost point, as we said, in odd, and in even you take the average of the two middlemost measurements. Here is an example. We have these digits, company salaries. There are 13 of them. And the middlemost one is the seventh number now is 152. So the median of this particular data set is 152. The mode is the population of a population or sample is the measurement of the most frequently repeated number. Let's say this is accounts data we have, and we have this data here, the observations, and those zeros are indication of the repetition. And you will notice that the number 16 was repeated 9 times, 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore, the mode of this data set is the number 16 because it was repeated the most. These were the measurements of the center. The measurement of dispersion or the variation are the range, the variance, and the standard deviation. The range is the largest number minus the smallest number. The variance is the average of the sum of the squared deviations from the mean. For example, if you have the mean in the middle, you will plot or put all the other data set. They will come up to the right and the left of the mean, and you will square these differences and add them up. The standard deviation is the square root of the variance. Let's see if we have some examples. Interest salary in thousands of dollars, for example. These are the data set that we looked at before, but now we want to get the range. So we will have to rearrange this data set from the smallest salary to the highest salary, and then we subtract the highest number from the lowest number. 241 minus 127 will give us 114. So the range of salaries is 114,000. And that will give you variation between the least paid person and the most paid person in that company. Now, the variance is, we said sigma square is the variance for the population. S square is the variance for the sample. And if you, again, don't get overwhelmed with the mathematical term or the equation here, but sigma square is basically the summation of the difference between each x and the mean, and we square that difference, and we keep adding the squared differences and we divide them by the however many or the count. So basically sigma square is the average of all squared differences. We square all the differences because we want to have a positive number, so sigma square cannot be negative. The sample variance is the very same idea. You get the differences between every single observation and x bar, and you square these differences and add them all up, and then you divide by n minus 1. Why do you divide by n minus 1? Because we want to give more freedom to the sample standard deviation, because the sample is so small. So we want to give it some freedom to count right, and this has been statistically determined, over how many 100 years or whatever. This is the equation we use. So it's always the number of sample in the sample set minus 1, and we call that just a degree of freedom. The standard deviation of the population is the square root of sigma square. This is why we call it sigma. The standard deviation of the sample is s, because we take the square root of s square, which is the variance. Population variance for the standard deviation. Population of annual returns for 5 junk bond mutual funds: 10%, 9.4, 9.1, 8.3, and 7.8. Let's say that this is a very limited population for the sake of example. To illustrate, so mu is the population mean, excuse me, is the all these percentages added up, divided by the number, which is 5, which will give us 44.6 divided by 5, or 8.92%. So the average return for all these 5 junk bonds is 8.92%. The sigma square is to take every single observation, subtract